Okay, so I have a spar. It's basically a mast here. I've got a compressive load P acting on this. Okay, I've got some dimensions. You can look at all those as you want to see. So I've got this. So I've got three allowable stresses, right? I it's under compression. It can allow 70 megapascals. The shear stress on the pin can be up to 45 megapascals, and then the bearing stress between the pin and the plates can be 110 megapascals. And the idea is, okay, well, what is the total allowable force? Essentially, I've got to figure out what the force would be for each allowable stress, and then figure, whichever one has the lowest force. I can't go any higher than that. So we'll go ahead and start with the compressive stress, the allowable stress. That is sigma allow, which again is 70 megapascals. Okay. And that's going to equal that compressive stress P divided by the area, right? And again, P is what I'm trying to find, what P is going to reach that stress. Okay. The area I've got a tube there. So it's going to be pi over 4 times the outer squared minus the inner squared. I always do everything in kind of the base units. So instead of millimeters, I'm going to use meters. Just like with megapascals, I used pascals. So times 10 to the 6 is where that comes from. So I use meters here. So that's 0.08 meters squared minus 0.7 meters squared all over P. So the P that will cause us to reach this allowable stress is 82.5 kilonewtons. When I do that calculation, I actually get 82,000 newtons. I just lopped it off, went to kilonewtons. Again, when I do my calculations, I typically do them all in kind of the base units so that my units always come out. So I always do everything in newtons, pascals, meters, and then I'll put in a mega or a kilo or things like that. I do the same thing with pounds and inches on the English side of things. Okay, now let's take a look at the stress. Okay, so tau allow is then going to be the shear stress divided by the area. So we got a few things to think about here. The first thing here, okay, well, we know tau allow is 45 megapascals. Okay, so let's take a look at the pin that we're looking at. Right, so I've kind of got this guy like that, right? And I've got a P pushing down on it. Now, if I think about that pin going across here, right? That pin is actually getting hit in two spots. Meaning, if I think about how I'm cutting it, I actually have to cut it in two places. I've got kind of a shear here and a shear here. So that shear force is actually going to be P over 2. This is called a double lap joint. Okay? And because it goes across in two places, right? Half of the force is on, one connecting plate, half is on the other. So that shear force is actually half of what it would be. Okay, so again, using my equation for tau allow, I'm going to start with the 45 times 10 to the 6. That's the allowable shear stress. My shear force is going to be that P that I'm looking for divided by 2. And that's going to be divided by the area. Now, this is the area of the pin, right? Because if that shears, it's going to shear across that circular pin. And that pin has a diameter of 25 millimeters. So that is going to be pi over 4 times 0.025 squared. Okay? So again, I've got that double lap joint. Again, it's the shears on that circle there. Okay? So from that, I can find that for that to reach the allowable shear stress, the force has to equal 44.2 kilonewtons. Okay, so at this point, I know this guy can't happen, right? Because once I hit 44.2, that the pin is going to shear, right? So the compression won't reach its limit at that point, right? However, I do have to worry about this bearing stress. And again, bearing stress is still just a force, the bearing force, and we'll talk about that in a little bit, divided by the area. Okay? Well, that bearing force is, again, what I'm looking at here, and I'm going to, hopefully this won't look too terrible. Yeah, that's where I screwed up. Boy, that's terrible. Hopefully you get the... I think that's all right. Okay, so again, this is that um, that plate pushing on that pin, right? It's that interaction between the pin and the plate, right? So because there's two plates, again, that force is going to be P over 2, and again, the allowable bearing stress is 110 megapascals. Okay, that bearing force again is going to be P over 2, because again, there's two plates, just like what we had with the shear force. Okay, but now my area is kind of the projected area, which is to say, again, that bearing stress is pushing kind of all along that surface. So it's just the rectangle that's made by that that plate on the pin. Okay, so that area for the bearing is just going to be the diameter times the thickness of that plate. So it's going to be the 25 millimeters times the 12 millimeters. Again, it's that bearing, it's that projected surface of that force pushing on it, right? So it's that interaction between the plate and the pin. It's a little hard to visualize. Hopefully this makes sense. If it doesn't, well, I guess contact me if you have questions. Okay, so from that, okay, I can find the P required to cause the bearing stress to become allowable is 66 kilonewtons. Again, that means that the shear is what happens, right? It won't fail in bearing, it'll fail in the shear first, because once I hit that 44.2, the pin reaches its limit, right? I never reach those other ones. Okay, so when dealing with this allowable stress, right, you kind of figure out every which way that it can happen and then kind of pick the worst case scenario with it. And generally, all of these stresses are just, force divided by some specific area.